Okay, thanks everyone. Who here did I possibly walk past at DDD but not notice because there was 1,400 people there? Hi. I didn't get to say hi the other day. Welcome. Today we have Varun and Aman from AWS. What was that, Brett? Congratulations. Oh, he's just going to be... So, Varun, you've just recently had a child?
Yep.
Boy or girl?
Boy.
Boy, 5 days?
Yep, thank you.
So, one of the reasons why we need to kick off more or less on time, because Varun needs to get home at a reasonable hour. Somebody commented to me before that, this is perhaps the first meetup, AWS meetup we've had around .NET, and you don't hear much about .NET in AWS. I don't know if you addressed this at all in your talk, but it'd be kind of interesting to know why some people might have that opinion.
Yep.
If it doesn't come up, maybe we'll ask it as a question afterwards. But
right.
Without any further ado, to you guys.
Hi everyone, welcome to our session, Accelerating .NET Modernization through a product development lens. I'm Varun. I've got Aman here who'll talk about some aspects of product development, .NET modernization. We're both cloud architects with AWS and deals or specialize with .NET modernization, or monolithic legacy software modernization is what our specialty is. All right, so let's see if this is working. 1 second. Maybe not. It is. All right, our agenda is pretty straightforward. So we'll talk about modernization, the challenges that we have, products over projects, .NET and AWS, somebody talked about it, so we'll see what our relationship is with .NET, and modernization strategies. That's our agenda for today. We'll start off with what is modernization, right? So now, modernization is a loaded term. We all know that, right? It could mean different things for different people. For some, it could mean just putting stuff in the cloud is modernization. Other would mean like re-architecting is modernization. Some of our customers feel if we resolve the existing bugs, that's modernization. So it depends on who you ask. You don't have a CI/CD pipeline? I'll give you one. That's modernization. Well, this is a definition of what AWS says is modernization. So it's the process of progressively transforming existing applications and infrastructure to extend into higher value cloud-native services that unlock new business capabilities, accelerate innovation, and reduce technical debt. Now, just to make things clear, what we'll talk about in terms of modernization is from monolith to swanky new services. I'm not using the word microservices because we'll talk micro, macro. We're just talking about services at this point. Let's not go into that debate on what's good or bad, but we're talking about legacy applications and how we move them to new services. Oh, we're going back. All right. Cool. Legacy applications. How many of you deal with legacy applications? Have you dealt with legacy applications? Have to maintain legacy applications? Oh, very little. Let me explain legacy applications. 5 years old, 10 years old. You have got logs in text files. Does that ring a bell? You do a deployment. You don't even know what's happened. Somebody else created a legacy app in your organization, and you know just bits of it. You're just making it work. That's what we call about legacy. That's what we consider legacy applications, right? Legacy applications deal with all these issues. Their size, in terms of size and complexity, they're huge. They're monoliths. Turnaround times are huge. You're unable to realize the full potential of the development team that you have in terms of legacy applications. There are comments from people who talk about and say that monolithic legacy application is a drama of its own. Every piece of the application is a drama. Deployment is a drama. You don't know what you're deploying. You deploy it. .NET developers here will know with legacy application. You do an IIS reset, and you don't know what's happening. With the IIS start, it won't start. What would happen? Will the service be unavailable for? You don't know that. That's what legacy applications are. Testing. Testing is like walking in a minefield blindfolded. You don't know. One wrong thing, people don't understand the application. There are no testers. Everybody has left. You just pray to God and say, things would work perfectly for us. So all in all, a monolithic application or a legacy application is this spaghetti monster where you don't understand what it does. People who built it no longer exist in the organization. You have to add a new feature, you don't understand. And that's where we have to move on from monolithic legacy application and see how we can modernize that. That's where both I and Aman fit in. We look at legacy monsters, these apps these granddad apps, which are still living, they're important, and we try to fuse new life into them, see how it works. Cool. So how do you start this journey? You've got this legacy application, how do you start this journey? And there are a few different ways you can do that. Now, what we have observed over a few modernizations that we have done, and things, product delivery is a great way on how you can, or looking at an application from a product lens, helps us modernizing the application, gives us very good ideas around how you can modernize an application. Before we go there, we'll talk about, every time I think about modernization, this phrase comes to my mind. The most dangerous phrase in the language is, we have always done it this way. Have you heard this somewhere? We have done this way. We have done it this way. This was said by Grace Hopper. Anybody knows who Grace Hopper is? Fred does? Nice. You do? Cool. Grace Hopper is an American scientist, naval admiral. She was the person who developed COBOL. Pretty famous for coming up with the word bug. And when she found bug, it was a literal bug in a huge computer which short-circuited a system, and that was the first time when bugs were introduced into systems. Well, modernization is just not about technical modernization. It's not about serverless or containers. It's this whole ways of working that you're supposed to modernize along with technical things like serverless and containers. It's a cultural shift that you bring in your organization, in your team, to ensure that modernization is sustainable. You do that using mechanisms. Now, mechanisms is popular in Amazon. We use that all the time. And what it means is, like we always say at Amazon, good intentions are good, but we need to go beyond good intentions, right? We need mechanisms in place, which are essentially processes which have been tried, tested, and are repeatable in nature. We come up with these mechanisms, and that's how we try to solve problems in a repeated fashion. What we'll talk about next are a few mechanisms that we have in terms of product delivery and why we think of legacy app modernization as a product. The first question is product versus project. Why is it not a project? We just modernize it. It's a project. What's the difference? So there's a difference in terms, at least what we think in terms of product delivery and project delivery. Now, project delivery has a scope. You do certain things, you're done with it, you leave. That's it, right? You bring in new consultants, they do something, and they leave, right? In terms of legacy applications who have been there through time, right? I think they are more important, and they need a strategic vision in terms of how or where they want to go. And that's where you need to think about that as a product. When you think about that as a project, they're not short-lived, they're long-lived things. They live forever, right? Till the time the product remains, the team remains. You have smaller teams. The teams are generally famous for they build it, they fix it, they support it. Right? You don't have different teams to do it. You don't have like people who build it and different people, they go away and people fix it. So it's thought about as a product. The key piece around legacy application and thinking of them as a product is also talking about customers, right? You need to think about customers in terms of legacy applications and work backwards from them in terms of what your requirements are. Now, we say working backwards from customers. It's pretty common at Amazon. We work backwards from customer. Why do we need it? The real reason for, at least in terms of legacy application modernization, is we need to understand who the real customer is. These legacy apps are so old that you don't need to modernize every bit of it. You need to figure out what's important for you. What's important for your customers now? They were built 15 years ago. If you start on this project where you start modernizing every small bit, it's wasted effort, time. That's where you need to understand who the customer is. Now, this is a tricky question, who the customer is. The common misconception is customers are in the retail world. This is the common picture of a customer, right? A customer is the person who pays the bill. Is that what your definition of a customer is? Anybody with a different definition here? Customer? Yeah. Who's using the application? Great. I think every time you build an application, you need to figure out the customer. And at times, your customer, we confuse the person who pays the bill to the person who's the customer. So if you're working in a consulting organization, you think whoever recruited you, like say there's a consulting organization and they want a new website to be created for there's a company who recruits a consulting organization, and they want a new website to be created. Who's your customer? Not the person who paid the bill or who recruited you. Customers are end users who will use the application. Figure those out, figure out their needs, and figure out what you need to modernize. If you don't work in consulting, you work in internal companies, right? You're in the IT department. You built a software for internal users, your finance department, let's say. Who's your customer? The finance department. You figure out what do they need, what are their requirements. Every decimal point matters what matters to them. So you be careful in terms of what your requirements are, who your customer is, and then work with your legacy application in terms of what are things that they need now, what needs to be modernized now. I think we spend a lot of time identifying a customer when we go into these projects where you have to modernize the .NET legacy application just to identify who the real customer is, because at times it's very hard to figure that out. They've been there for a while. There are a few other questions which we also ask during product delivery around customer, right? So first one is, who is the customer, right? What is the customer problem or opportunity? Which customer problem or opportunity we are talking about? Is the most important customer benefit clear? How do you know what the customer needs? Is there a way to measure it? Do you know what they really needed? Have we done surveys? What is our mechanism to know what they really need? What does the customer experience look like? These are 5 questions we normally ask in terms of how working backwards from a customer and figure out that vision in terms of that legacy application. We answer these questions, we move on, and that gives us a vision in terms of where do we want to go with this legacy modernization. Again, you don't need to modernize everything. Modernize the parts which are important. Prioritize the parts which are important. This concept, at Amazon, we have a working backward document where we create a PR FAQ with visuals. What that essentially is, we create a press release in the future. So it's a future press release, like an year down the line. This will be released. This is the customer. We add some frequently asked questions, both from a customer perspective and stakeholder perspective. So the questions are different. Customer questions are questions which the customer would ask. How does this feature work? How is this feature different for something else? And then we also add stakeholder questions, which are like, what would this cost me? How big of a team do you need? So we create a PR FAQ, which is just a working backwards document to figure out what that vision is, who the customer is, and then what would things look like. We have low fidelity visuals initially where we just draw and explain how things would look like, and then eventually we come up with a high fidelity solution. Now that's one of the mechanisms that we have at Amazon, but customer and thinking about that is everywhere. Even your Scrum Agile stories start with, as a dash, I need to do this. That dash is the customer. I normally say, figure out the person who will give you the standing ovation at the end, who will be happy, who will be elated. You did this modernization project. Who is that one team, one person who will be saying, oh, wow, you changed my life. That's amazing. Now I can do more releases faster, quicker. So that's the first mechanism around product delivery we try to use in legacy modernization. The next bit is tenets. So tenets is a mechanism to supercharge your decision making. Can I ask how many architects are there in the room? How many times do you have run into decisions which have lingered on for weeks, if not months, where people are just quarreling on this is good, this is bad, these are the pros, these are the cons around that? You see more of these in legacy modernization. When you see a legacy application, every now and then somebody would say, let's fix this, let's fix that, let's fix something else. How do you supercharge this decision making? What we do at Amazon is we come up with tenets initially. Tenets are these guiding principles for an organization in terms of what the belief of that modernization is. So it says organization here, but it can apply to a team. It can apply to a department. It's just basically a set of principles that you define that will simplify your decision making. An example of that is we'll prioritize or we don't want to disrupt. We want to minimize disruption. Right? So that's an example of our tenet. We minimize disruption. What does that mean? Is any choices that you make, anytime you have a decision whether this is good or this is bad, your tenet will help you to say that, you know what, we want to minimize disruption. Let's choose this option over the other because that's our guiding criteria. What you see here, or the bullet points there, are some of the characteristics of a tenet. So your tenets are supposed to be durable. What does that mean? Your feature could fail, right? Your release could fail, but your tenant should still stand out. It should still mean the same thing. Your underground foundation should remain the same. Tenants occasionally create tension. So we generally come up with 5 to 6 tenants. We don't create a lot of tenants. And at times, those tenants create tension. They contradict each other. For instance, there could be tenants which says deliver faster, and there could be another tenant which says optimize cost. Which one do we choose? And it depends on which stage are you at that moment. Maybe you are launching a new product, you're doing things initially. At that point, you have to show some speed. Now, you've got a few customers, and now you things are suddenly scaling. At this point, you want to optimize costs so that you have more resources available to do or provide new features. So it depends on what stage you are in. And the last thing that we have there is we keep tenants unless, actually I missed one. We try to be concise with tenants. So we don't want like this whole book of 1,500 tenants there, have 5, 6 tenants. Unless you come up with a better one, right? If you come up with a better one, we can change the tenant for your app modernization. One of the other things that tenants do is it promotes trust. So as an architect, I don't have to be a part of every decision making. I've defined these tenants. I can trust people. They can go to a meeting. These are our tenants, and they can align the decision based on that tenant. So it promotes a lot of trust in your team. Our guidance is that you define these tenants up front. You come up with a modernization project, start off with your tenants up front. Define those tenants, which are durable, concise, creates a bit of tension. See what's important for you, what is the eventual goal, and that will help you in this decision-making for modernization. Here's an example of some of the tenants that some of our teams use. So look at the first one. We consider the complete customer experience to minimize disruption. Right? We're talking about, we talk about the full experience, right? We don't want to modernize. We don't want to use, let's take an example, right? We don't want to use NoSQL just for the sake of NoSQL. Think about upstream, downstream applications which will be impacted. What's the value that you're bringing to the whole enterprise than just your app? We think big, execute small, fail fast. Again, figure out ways, how would you fail fast? That's what the tenant talks about. We design for failure. We use data to make decisions. That's how we write tenants. That's tenants for a team which are into modernization of a legacy application. What you'll see throughout this presentation is we'll talk about these tenants and how they come in action. How are they used? All right. Next is how to decompose your monolith. So you have this .NET legacy application. You have these product development principles that we talked about. You figure out the customer who's helpful, he understands, who helps you prioritize the requirements. You figure out tenants for decision making. But now, how do you decompose a monolith? There are a few different ways how you can decompose it. Now, the problem with monolith decomposition is it's not an actual science. You have to try it, see if it works for you. Every customer is different, every project is different, every app is different, right? And there are a few different ways people do it. People do it by business capabilities. So you have an organization which have sales, marketing department. Each department would have its own service. The benefit of that is you basically still have a decoupled system. You have these services which are owned by certain departments. The problem is slightly coupled with the business capabilities. As the business changes, as the departments change, you need to change the architecture of your decomposed service. Subdomain is another example of how we decompose a service. Subdomain is commonly known as DDD. So we use DDD, domain-driven design, to figure out what our services are, what are those boundaries, which services should be the outcome, the final outcome which should be created. The only problem with DDD or domain-driven design is at times it creates a lot of services. So we have to be conscious of the fact that when we create a lot of services, somebody has to maintain it. People should have the right tools to maintain it. You should have observability in place and all those aspects in place to maintain it. Transactions is another ability, or transaction is another way to decompose a service. So you have a distributed system which has a long-running transaction. You can essentially put that transaction as a single service. So multiple things which are happening in the transaction is just one single service. The benefit of that is that you have these fast-running services. There's no eventual consistency, right? It's a single service doing multiple things. You have your system is strongly consistent. The problem or the cons with transactions are that at times if the transaction is huge, it does many things, it becomes a mini monolith of its own. So we'll have to make a choice in terms of if transaction is good for you. Service per team goes a bit further from business capabilities. You know how we were talking about business capabilities and a service for every capability? Service per team goes a bit further. It goes, every team maintains a single service. They're responsible for that service. They do everything, the development, testing, release of that service, and there's a single team for that. So it has its benefits, but it has its cons in terms of when you have to do a bigger feature, multiple teams need to be aligned. You need to ensure that all these different teams are aligned in terms of what they're supposed to do, their strategy, their priorities. So if you segregate your application based on services per team, those are some of the things that you can consider. The last two things there are the Strangler fig pattern and abstraction pattern. They're mostly in brownfield, like legacy applications. How do you break your application apart or without disrupting the application? Strangler fig is a pattern created by Martin Fowler. What it means is you look at your application, which is a list of services. You work from your leaf nodes, extract, basically create a proxy at the perimeter of the monolith, which could be an API gateway. All your API calls or to the monolith are going through that, and then you reroute to your modernized services, one service at a time. So your edge services are modernized first, and then you go to the root of the services or the core service, and then you modernize that accordingly. So this allows you that you gradually move from a monolith to a microservice or a service-based architecture. Yeah. Abstraction pattern is very similar to Strangler fig, but what it means is when you have to modernize a core service. So if there's a core service which has upstream dependency, they're using it, and you don't have the liberty of working on the perimeter, you use something called the abstraction pattern. And the way it works is you create an abstraction of that particular service which is being used by upstream services, modernize the service, and then point the abstraction to the new modernized service. So these are a few different ways. Again, there's no right or wrong. People use some of these as a combination on what works for their teams and what can grow, where can it go. I've got a quick crash course about DDD. If I talk about domain-driven design, I'll take the whole session. So I'll just do a quick crash course. We use DDD, as I was saying before, DDD is a good way of modernizing your or splitting across your services, and works very well with microservices. So the DDD approach is, or domain-driven design approach, is that you align software with real-world problem domains. I'll take an example here, right, and then we can go through these different terms here. So we'll talk about an example. Let's say I'm building a library management system. You have to issue books. You have patrons who are checking out books. And let's talk about that in terms of DDD. DDD says that your system should be aligned around the real-world domain. The domain here is library management system. Then you talk about a ubiquitous language, shared jargon for effective team communication. The ubiquitous language that you have in DDD is around business. So if you're talking about a library management system, let's say the term checkout. What does checkout mean, right? Does checking out mean checking out a book? Does checkout mean checking out a book, borrowing a book? Or does checking out mean checking out code? Different people in your team could have a different definition of what a checkout means. A ubiquitous language initially defines what does it mean from a business perspective. So for library management system, that means borrowing a book. That's what checkout means. That's what we'll use throughout our application. You have got bounded contexts, which are, in simple words, just subdomains inside your bigger domain. So if you're talking about a library management system, your user management could be a bounded context, your patron management could be a bounded context, book system could be another bounded context, a subdomain underneath your bigger domain. A bounded context is a good boundary for a service. It's huge, it's a big one, but it's a good boundary where your service should fit. Then you have things like entities and value objects. Entities are nothing. In the case of library book is an entity. It's got attributes. It's got the title, author. These are an entity, and value is something like a date. It's nothing by its own, right? It needs an entity to define what that value is, to understand what that means. So entities and objects are just things like books, users. These are all entities. And then finally, you've got aggregates. So aggregates is a combination of entities which you create. Think about it this way, right? So every time an entity changes, something else changes. They are good candidates to be part of an aggregate and good candidate to be part of a service. There. In case of library management, an aggregate could be patron management or patron, which is basically responsible for the user, details of the user, as well as the books they issue, what are they issuing, what they've checked out, what their date is, how much fine do they owe to the library, things like that. All these things could be part of an aggregate. So these are concepts of DDD, and where they fit into service decomposition is a good boundary for your service is between a bounded context and an aggregate. So great case, if it's an aggregate, great, but sometimes create many services that you're supposed to maintain. Bounded context is another boundary. So ensure that your services are somewhere in between that boundary. If you want to know more about DDD, obviously you've got books on that which talk about that, but that's a quick summary of how DDD and how does it fit into service decomposition. All right. Next is, so what about .NET? We have been talking about just product delivery, service decomposition. We've got Aman here who will specifically talk about .NET.
And try to explain it to me. Cool. So I'll try and cover the part everyone is here for, .NET. This is one of the first .NET talks that we've had at Perth. Before I start, how many people here know what .NET is? Cool, great. How many people have written some C# code before? Awesome. How many people have written a .NET Core application before? Oh wow, we have quite gathering from .NET experts here. You probably know more than I do for .NET, so feel free to chip in. Cool. Let's start with flavors, right? .NET flavors. .NET framework, the old legacy runs on Windows flavor, right? Most monoliths are in this. They're in .NET framework. This is what you want to get away from, and I'll tell you why soonish. The version supported right now, the one that Microsoft supports, is 4.8.1. Doesn't mean anything right now. Will do once you've looked at it before, because there have been multiple versions across time, which sometimes don't make numerical sense, but that is an inside .NET joke, yes. .NET Core, this is the future of .NET. Everyone who is a .NET developer should generally move to .NET Core. This, I think version 8 is supposed to come out soon. Microsoft basically holds two types of supports, LTS and STS. So STS stands for standard term support. So they'll support one particular version for about 3 years. Long-term support they'll support for 3 years, and STS would be 1.5 years. So even numbers generally would be supported for 3 years, odd numbers 1.5 years. So very interesting on how they've come up with that. Then the good thing about .NET Core, it can run on anything. You can run it on Windows, you can run it on Linux. How many Windows fanboys here? You're not going to like my talk. Okay, cool, awesome. Cool, great. I'm glad it's just one person and they're the organizers, so they can't throw me out. So. And what is .NET Standard? This was an interesting one. I did not know about this before. It's basically a set of specification, API specification that works across both. So when you're looking for compatibility across framework and core, try and think about .NET Standard, right? That's generally more often than not the answer. More often not the answer, not, yeah. Cool. So what does a typical .NET modernization journey look like? We start with a .NET framework application, big pink .NET framework running on Windows, big monoliths, think about big EC2 servers, single point of failure type situation. You try and basically port all that code into .NET Core. That can be a huge undertaking. The project that me and Varun are working off right now has 7 million lines of code. Can you imagine how many bugs would 7 million lines of code have? I don't even want to make a guess on that. It's about 1,300 endpoints or so. So it's a quite a big code base to go from .NET Framework to .NET Core. Once you've done that, you can then split them across into microservices, which will run seamlessly on your lambdas and your containers in event-driven patterns and all that beautiful stuff. That generally is the journey that people take. They try and port their code from framework to core, and then they split it into microservices. There is a second variation to this, where they start with, again, a pink box, which is a large monolith .NET framework. They try to split the framework in smaller frameworks, right? And then basically they iteratively go and start porting them into .NET Core. The benefit of this approach is that those .NET framework can still become microservices, right? You can still run things on Windows containers. You can still make them decoupled, loosely coupled, high cohesion type services, and then iteratively work across services that matter the most to you. Essentially, these are the two variations that you generally go with. So these are what typical .NET apps look like. The big A there is, I'm trying to denote a monolith here. 1, 2, 3, 4, 5, they are libraries that this monolith uses, right? That is your best case scenario. You've ended up looking at a monolith where you've seen that there's isolated libraries that only this monolith uses, but generally in organizations you have the latter, which is you have shared libraries across different monoliths. So it's more fun to take them out. So as I said, this is your best case scenario. So this is a bit simple. What you do is you modernize your .NET libraries to .NET Core libraries, .NET Framework, .NET Core, and then you basically take your app from Framework to .NET Core. What do you do when you have multiple monoliths sharing this stuff? Can you even go from a pink to a green, so from a Framework to a Core? Generally, you can't because your apps would break. Your libraries will be in Framework, your monoliths would be in Core, it wouldn't work. So this is the general answer you take when that happens. You can take your framework libraries to .NET Standard, which I talked about is the cross-functional framework that works across both .NET Framework and .NET Core. And what that would mean is the first piece of work that you would take is that you would take your .NET Framework libraries, you would change them to .NET Standard, and then you would repoint those monoliths to these new libraries. And then you can go to .NET Core with your monolith, which means that it can run on lambdas and microservices and whatnot. And this can still talk to the same library set. Now, for all of the DevOps fanboys in the room, there is a variation to this as well. Generally, you can use some Git magic if you go down the pathway where you've decided to break the framework apart first. So what you would do is you NuGetify these packages in your personal Git, right? So instead of talking to the NuGet org, you have these custom packages hosted in your organization, and you switch on Git tags, right? That basically gives you version 1s talking to .NET Framework and version 2s talking to .NET Core. That way you can work across both of these things. This, in my experience, has been the most feasible way to do it to minimize the disruption. So I'll try and answer some questions on this later on. Cool. What tools does AWS have to help you? Porting assistant for .NET. Basically, consumes your solution file and then gives you a list of all the dependencies in your 7 million lines of code, right? And whether they would be compatible with .NET Core and the version that would be compatible with .NET Core. So it gives you sort of a map that this is how you go from library X to library Y. Microservices extractor. You upload a solution file in here, it does some magic, and it tries to create microservices for you. You can even use that to extract microservices out. You can basically group different microservices together and then extract the whole lot out. And then there's app2container. This is basically a command line tool which allows you to extract .NET and Java applications into containerized formats so that they can run. Try these tools out. They're quite interesting. I did not know about them a year ago, but yeah, they're quite handy. Cool. Varun talked about the theory. I'll talk about the practical. Tenet in action. We achieve more with less, right? So how do we achieve more with less, right? If that's my tenet, everyone cares about cost. People care about cost to improve their profit margins. people care about costs because they can achieve more with the same budget allocated to them, go for Graviton. Graviton all the way. These are just some cost comparisons based on 2 virtual CPUs and 8 GB of memory, right? If I run it on Windows, that's 146 USD a month, approx. Like, it could have changed. I don't know. ECS Fargate on Windows is a little bit more expensive because you don't have to manage the patching and underlying stuff, right? The downside of the other thing that you would have to think about when you're doing Windows containers is that, how are they going to domain join? Are you going to be managing service accounts and group service accounts with the domain, that sort of thing? I haven't played a lot with Windows ECS Fargate for good reason. And then we have our favorite flavors, that is Linux, right? Everyone loves Linux, I hope, except for Mr. Vicent. Linux is awesome. Linux is cheap. No problems of domain joins. What is that? And then there's a variation up where you go to Graviton, right? Much cheaper, 40% cheaper. So when you start talking about your Windows servers, you've basically gone and you saved your cost. Now think about big servers and big microservices over big projects, right? So one of the value proposition that modernization has is cost, right? You don't have to worry about licensing costs. Generally, in modernization projects, you also move from Windows SQL servers to Postgres. No licensing costs there. That's where you basically sort of recover, and it kind of pays for itself if you've done it well enough. So, cool. Docker files. Anyone written Docker file before? I'll try and quickly go through some code. I was thinking if I should do a live demo, but I decided otherwise. Cool. So how do I Dockerize on Graviton? That's the question. Now, the lovely part about .NET Core is that it does not need an IIS server to run. It can run on something called Kestrel, right? I did not know that before I touched .NET Core. I thought you needed an IIS server to run it. And because it can run on Kestrel, it can run on Linux containers. And because it can run on Linux containers, it can run on Graviton, right? This is an example of how you can build. So this is a multi-stage pipeline, right? For those who don't know what that is, you basically use one stage to prepare the image and the second stage to do something else with the image. So stage 1 is that I'm just basically talking to my internal NuGet source, right, to build dependencies, restore dependencies, and basically getting a version which is self-contained, which means that it has the runtime in there along with the code. And then I just copy it to a Graviton container. Once I copy it to a Graviton container, it just runs. So generally, you want your containers to be small in size. You don't want to have a lot of build tools in there and stuff. So when you do this, your containers are much smaller in size, which means that they're pulled faster from ECR. They take lesser space on ECR. And obviously, running on Graviton, 40% cheaper, 40% better. Cool. So that was the first tenet that we covered, which was do more with less. Second tenet is that we consider the complete customer experience. Enterprise disruption, modernization projects, that is like one of our aims generally is to minimize enterprise disruption. Now, the honest truth is a lot of us work in resources companies and companies that are not tech. Tech generally is an auxiliary function. So when there is an IT outage, we all know how the story goes and stuff. So we want to minimize enterprise disruption. Cool. As I go deeper into minimize enterprise disruption, I want to ask a philosophical question. How micro is micro, right? Monoliths are bad, yes. Microservices can be too much. So what's the size that you want, right? And as Varun was saying, there is no silver bullet to this. So I will tell you the pros and cons of what you can do, and then you choose based on your teams, your team sizes, your organization sizes and stuff, right? The first picture there is something that's called a lambda lith. Imagine running 300 odd endpoints within the same lambda. We've all done it before. We've hosted Express applications in lambdas. We've hosted web API, .NET web APIs in lambdas, and we run that. That actually, based on AWS documentation, is an anti-pattern. Use it if you must, but if you want to use that, try and run your microservices on containers, much cleaner. The holy grail on greenfields is that everything's a small microservice. But then with too many microservices, your production bugs can become like a murder mystery, right? You don't know what went wrong unless you have very good tracing. So choose your poison. How big is your microservice? That's an answer only you can give yourself, and you can decide as a team. But you can do all of it, and that's what's more important, right? You can go monoliths, you can go lambda-liths, you can go containers running 300 endpoints, you can do granular microservices. Cool. Another important decision to make. Do I have one database per microservice, or do I have a shared database for all my microservices? That's an interesting one, right? And again, like all my answers, the answer here is it depends. They both have pros and cons. Do you want to redesign your data plane? That's the question you got to ask yourself, right? If not, then you probably fit in that scenario where multiple microservices are going to share the database, right? If you want one part of your services, for example, only one part of your code base deals with time stream data, and another part deals with graph relationships, right? You might want to use Neptune for that part and time stream for the first part, right? In that case, you probably better off with this approach. Now, they have their own challenges. When they don't share databases, you have to work a little bit extra hard to work through what a distributed transaction looks like, right? Cool. So,
Aman, are you referring to a shared database as in shared infrastructure, like a shared RDBMS instance, or a shared schema?
a shared schema.
Okay.
Yeah, so you basically have the same set of tables across different microservices. Alternatively, you have them as separate entities altogether. Cool. Strangler fig. What is a strangler fig? I think strangler fig means like a big tree, right? Of fig. I don't know. English is not my native language, so yeah, okay, cool. So what do you do with a strangler fig? Do you just burn the tree down? What do you do with the monolith? Do you just start afresh? Right, let's just go start afresh, right? Big project, new team, great. No, strangler fig is one of the least disruptive things to do, right? Consider this. This is a monolith, right? Assume a simplified monolith. There is a UI, there is a user service, there's a cart service and account service within the monolith. In here, there's a dependency between the cart service and the user service, and they're all talking to one single database, right? One picture of a monolith. The first thing you do, you introduce a proxy, right? This helps you reroute things as you see fit. You don't have to go to the same flow of control for everything. What it also helps you do is build new features while you're doing modernization. So half your team decides to do new feature, no worries. Just build your feature and add it to the proxy, right? Your UI can still call it. Now this next slide is going to be a little bit convoluted, and I'm going to try my best to explain it. An anti-corruption layer, what is that, right? Think about an adapter if between two services. Service A talks to service B, right? And you're talking to service A, essentially. So in this case, the proxy was previously going to cart service, and that was going to user service. But now you have added a layer in between, which is like an interface / adapter that translates your call from service A to service B. That basically would allow you to bring the service B out, right? Because you're still talking to that facade or that anti-corruption layer and allowing you to move the services out. And slowly and steadily, more and more services come out of the monolith until monolith no more, right? And that's how you essentially reach using your anti-corruption layers and your strangler fig patterns through a modernization journey of a big code base. What does it look like in the real world? I just showed you boxes. What does it look like on AWS? Good question. Thank you for asking. Once upon a time, there was a team which had a big monolith. The monolith had .NET MVC front-end, server-side rendering, back-end .NET Web API. They hired some developers who were very excited by Angular and React. They tried to rebuild the front-end into A single page application, single page application was a fad a couple of years ago, and everyone just uses SPAs now. They host it in CDNs and S3 with authorization at edge with Azure or Okta or whatever they use as their IDP or Cognito. That's the favorite, remember? And before they knew it, they were already on their modernization journey because they split the UI out. Now, this UI is obviously a public interface. Your IaaS server is sitting somewhere on your on-prem, right? You're trying to modernize that. So you kind of need a way to connect to it. So you decide to use a combination of an NLB and an ALB to translate that call throughout. Use some transit gateway and direct connect magic. If you have networking questions, there's John, there's Brett, ask them. But this just works. And that is how your front end in AWS is now talking to your back end inside your on-prem server. But it's still an IaaS server, and you shouldn't be depending on IaaS reset for your bread and butter, right? You decide to first introduce a proxy. So you can use like a double proxy, almost CDNs like CloudFront have different behaviors. One behavior can point to the actual source where you get the JavaScript and HTML to render on your browser. The other one can be pointed to an API, right? You can also point it to an API proxy, right, which you can use to route the calls, and you can basically use your native patterns of API gateway to Lambda to a database, and you can start splitting those services up. As you go further, your monoliths become smaller and you get more microservices out. And eventually you end up with a cleaner picture where you can decommission your monolith. That's what it would look like in the real world actually that's what it looked like in the last project. So I'm not going to tell you what my last project was. Cool. This is one of the most important tenets. We design for failure. Assume everything fails. And this man said it. Everything fails all the time. He also said the world is asynchronous. I was doing some training before, and I loved the video that he did. Everything fails all the time. Design failure. So distributed computing generally makes things a little bit harder, and you got to work a little bit extra on your designs to get them to work. I'm just going to introduce a couple of concepts before I delve into a couple of patterns to do failure design. Orchestration and choreography. Orchestration, think about an orchestration in an opera house, like an orchestra playing. There's one guy who's orchestrating the flute players and the singers and everyone. And choreography is almost like a dance, right? Each microservice is not directly talking to each other, but they're taking cues off each other, and these cues are events, right? These are generally how microservices communicate with each other, one of the two. Orchestration is more of request-response type of scenario. In AWS, I shouldn't say best because I think I'll piss at least one service team off, but one of my favorite orchestrators in AWS is step functions. So try that. That is amazing. I don't know how many integrations that it has. You can almost write a full app without writing any .NET code if you wanted to. And choreography, generally EDA architectures fall into this space, right? Multiple apps are talking to a central event bus, and everyone's listening to the events that they're interested in. So service A does something, produces an event. Service B reacts and does something, then service C reacts. Choreography generally is more preferred when it is about like large scale volumes and stuff, because everything is loosely coupled. There is no dependency on the central orchestrator. You can easily take things in and out because all you depend is on the event, not the thing that produces the event. And especially when you want to talk to external systems. So there's a lot of event bridge integrations with external systems. So you can chuck in Salesforce data and stuff like that and react to those type of events. It's quite cool. Why did I talk about this? Because I actually this is an example of a step function. If people haven't used this before, I'm sure here at an AWS Meetup, people have at least seen one ASL, Amazon States Language State Machine. This is an example of what Event Bridge would look like with different services, producing events and other services reacting to it. But what I'm more interested in is distributed failures and how to handle them, right? So we can briefly talk about the saga pattern. What is a saga? A saga is basically a saga pattern is basically meant to solve distributed transactions, right? You've gone and you've tried to withdraw some money from a bank, or in this case, you've tried to place an order, right? Which needs to call the inventory service to fulfill that order, and then it also needs to call the payment service. But something happens in between, and that call between the two services failed. You almost need to do a revert back, right? So you have to think about these reverts. You cannot always think about success case scenarios, like what happens when I get a good event, what happens when there's a network failure, how does your retries and your back-off mechanisms work, are you able to revert that, that failure, right? So on the top is an example of a choreographic saga where, you know, when you go from an order service to an inventory service with an order placed event, if something fails, then you have a way back for inventory service to produce an event which the order service can sort of consume to revert back what it did. Whereas this is an example, at the bottom is an example of a saga orchestrator. So you can use step functions and branch off with different states in there to revert the previous states doing. This is an example of what a saga pattern looks like in a step function. So basically you start in Lambda, you invoke place order, check if your output of the Lambda is correct. If it is correct, then you go to update inventory. If it's not correct, you got to revert inventory, revert the order placement. Same thing goes for inventory. If it works, you move on. If it doesn't work, you got to revert it. So that's what basically a saga would look like. So when you're doing distributed transactions, something good to keep in mind. Cool. One of my favorite topics, observability. Who here has tried Lambda Power Tools? Awesome. If you like this talk, or if take my word for it, try it. You're going to love it, is what I will say. Lambda Power Tools is awesome. They work through tracing, logging, and metric. One library, three sub-libraries that you can include as part of your code, which can basically switch on the lights to what's happening inside your microservices. And when you start making and building a lot of these microservices, you definitely need the lights to see what's going on. So this is an example of what tracing looks like. So X-ray allows you to see through what calls have gone, what timings were, you know, how long it even took for the cold start to occur, and then the Lambda to do what it meant to do. You can even define stuff like segments and subsegments within your Lambda. So imagine you had 5 functions to call within the Lambda. You can annotate them and know how much each of them took in real time, not in your local computer where you're trying to understand, you know, where the bottlenecks are, in real time and how users use them. You can also use custom metrics based on Lambda Power Tools. So a 400 error or a 500 error is extremely generic, right? Inventory service failed to call something. That metric might be more useful to you sometimes. So you can instrument your apps with metrics that are more meaningful to you. And gradually you'd be able to take your operational posture up. Cool, TLDR. What did we cover? Established tenets early. These are guiding star. I almost don't like architecture meetings anymore because everyone has an opinion and everyone is right and everyone is wrong at the same time. So tenets will help you answer the question on what's important for your team as a collective. Everything fails all the time. Design failure, observability is key. This is the last thing that we talked about, but one of the most important things. I think I'm missing a heart there. Thank you, Varun. You've updated the slides. So .NET Love AWS was the thing. There's a picture that is missing now, but yeah. Why do you do modernization? You do it to save cost, to make your features faster. You know, when everything has its own life cycle. Developer Joe does not break developer Nick's code, right? In a completely unrelated place. choose where you fall within the spectrum of a monolith and a microservice. There is no right answer. Work out what's best for your team. In one of our last projects, we went for macroservices, where when we had to split 1,300 endpoints, we actually split them across 12 or 13 macroservices, because having 1,300 microservices would have been an operational challenge. Oh, there's the heart. It is there. Modernized by business value, modernized by product roadmap. Work out what features are most important. If there is a feature that no one's going to build new feature, like there's a service that no one's going to build new features on, or it doesn't have users, there's probably not enough merit to modernize it. So that's why knowing your customers, knowing your priorities is important. And that's about it. We'll take some questions.
Any questions? Has anyone done .NET modernization? Have you guys moved from monolith to microservices?
Do you have a question, Lloyd?
What was the experience? Have you done that on AWS?
Yeah, it was on AWS. So, yeah.
Oh,
Moving, a large monolith into AWS microservices. No question.
Yes, Jen.
Is there anything special you have to do to make things run on Graviton?
As long as something can run on Linux, my understanding it can run on Graviton. The base image for Graviton containers is a little different, and it might not have the tools specific to build your application. That's why you use like a multi-stage kind of pipeline. You build your thing and you chuck your DLLs in, and it just works. It's kind of magic. Yeah.
What is Graviton?
Good question. Underlying CPU architecture. So it's also denoted by ARM64. So you must have seen x86, x32 type notations. Graviton is underlying CPU architecture that AWS released not too long ago, about a couple of years, I think, or so. But it was very interesting because we were modernizing the project, and every month we were adding more services in, and our cost was getting lower, weirdly enough. I couldn't work out why, and like the containers were very cheap to run on Graviton, and we cost sized them. So, but try them. Try Graviton, see how your monthly bill looks like. Try it for one microservice, and I promise you're not going to go back. Go on.
Do you ever decompose the, like I know you had Lambda functions there before, do you ever decompose them into single purpose Lambda functions that are running on C#?
Yes, sometimes. For greenfields, I prefer having Lambda functions that run a piece of C# code. It also depends on like some of the frameworks that you have, right? Like SLS or SAM frameworks that you use. If you have everything in order, then spinning out and maintaining a new Lambda function can be really, really quick. But if you have to think about deploying them and managing them separately, then it can be hard. So when you couple that with infrastructure as code, generally it's you can do it. Especially for greenfield applications, go for it. For monolithic applications, personally, I prefer to have a little bit larger chunks because I would be doing the equivalent of rebuilding the application if I was taking out every single Lambda out, which sometimes our projects and timelines don't cater for. So,
just to add on to that, the cultural shift when you go from a monolith. So you talk about the team which is maintaining the monolith, right? And suddenly you start introducing them to microservices, all these 10, 15, 20, 100 microservices. It's very difficult to train them or get them on this journey. So we have to create these checkpoints in between to ensure that they understand these services, they understand the observability, all the things around it, and they move on further. And this is a two-way door, right? You can always decompose a bigger service into smaller services can be combined into bigger services. If every time you're changing one service and you have to change another service, it's a good indicator that you have to combine both those services together. So that's the reason why we start small and then we go from there.
more art than science.
Yeah. Do you normally run them as like a web service on Lambda that has some sort of layer in front of it that calls downstream, or is it stuff, do you like re-architect the entry point to the application to be like a native handler for Lambda?
Sorry, good question. So this, let me just get back the slide so that I can answer this better because it's a bit visual of what you've just asked. Yep. This. So you have an API gateway proxy generally, right? You can have custom domain names on your API. So when you first create an API gateway, it has a name that you can't remember, but you can always go and get your own name from Route 53 or like use a custom domain name. And then you can establish routes which have direct native integration to Lambdas, right? Alternatively, you can send it to ECS containers as well. So you use the API. I've generally used API gateways as proxies. I've used application load balancers as proxies. Even they can talk to ECS containers or Lambda functions. What else have I used as proxies? Have you used any more proxies? Those are the two general ones that come to mind. And there's two versions of API gateway. That's probably why I think there's three. So there's the REST API and HTTP API, and you can use both of them depending on what you prefer. Go on.
Using Kestrel and the Lambda function anymore, it's directly invoked.
Sorry, say that again?
Like, if you're running on like a .NET Core application on like a container, it's running on Kestrel, right?
Yes.
Yeah, but then in a Lambda function, you're taking that away and you're just invoking it via the handler. Is that?
Yeah. So
I think under the hood, it still requires Kestrel to run. So if you're running .NET runtime on a Lambda function, you're running a Kestrel container. If you're inside in the micro whatever firecracker, but if you've written your own container, right? Even then, when I said that self-contained equal to true in my Docker file, I'm saying that I'm bundling up all the tools that it needs to run, which is going to include the Kestrel container. Yeah.
More questions? Please join me in thanking those gents.
Can we please ask, we can please put the survey result up, just so that we can get you to fill out like 2 or 3 questions for us, please, if you enjoyed the chat. Why did I do that many slides? There you go. There you go. Cool. Awesome.
All right, just bear with me for 1 minute. Maybe you can fill in the presentation. We're just going to bring up something to close out the session.
Cool. Thanks, Christian.
Thank you.
Surely there were more questions.
If you're just curious, right? Like .NET on AWS is a big thing. Like there are quite a few different options in terms of how you can run .NET workloads on AWS. Pretty sure I read somewhere in terms of Microsoft workloads, AWS runs the most amount of Microsoft workloads against anyone else. So which means you've got options, both from serverless as long as EC2, serverless containers, you've got all the options there.
Just a comment about the Graviton thing as well. So in 2014, Amazon bought a chip maker called Aman Labs. And so they construct, design, build for us custom chips. So you would have heard about Nitro, which is the hardware hypervisor that we use. So that is built by Aman Labs. All the offload we do in the machines in terms of offloading network and storage and things like that are all custom chips made by Annapurna. And so because they're a licensee for ARM, they build ARM CPUs for us. So we're now up to the 2nd generation of Graviton, which is our brand name of the ARM CPUs. And so it gets 64 cores, and it is optimized for cloud usage and for multiple threads as well. But because we're doing it in-house and we manufacture in-house, the cost is very, very low, which is why we get the cost savings, but you also get the performance boost because we've designed it that way. So you can run your Lambda functions on ARM CPUs if you want to. You can run your whole instance on it, and of course you can run your containers on it as well. So the only thing that doesn't run on there is like native x86 executables, right? But if you have an option, it's definitely worthwhile. We had a very, very, very large customer who I cannot name, who merely, because all of their code was written in, I think it was actually PHP and now running on Apache, so please don't do that in the real world, but they did. They had a fleet of tens of thousands of machines, and they switched them all to the Graviton, so the ARM CPUs, and they dropped their fleet by 30% in terms of size, and also more in terms of cost because the actual instance costs were lower as well. And also they can pack more in, so yeah, definitely worth a go if you are in that space and to do it in .NET obviously works for that.
Is there any limitations?
I'm sorry?
Is Is there any limitation?
Limits.
Limitation using Graviton?
Other than not running x86 code, sure. I mean, if you've got libraries that would, and again, .NET doesn't fit in with this, but if you've got traditional, Windows libraries or traditional Linux libraries that compiled on x86, you can't just copy them across. You have to recompile. But any of the interpreted languages, so .NET, Python, Java, and stuff like that, just run. All the fleet of stuff that I do personally in my home life and all the stuff over in AWS, my default go-to is to run on ARM just because it's cheaper and it's faster.
Nothing specific with Graviton as such, but ARM64, every time .NET releases a version, they have certain guidance in terms of how does it behave with ARM64. Now, general applications won't even notice an issue with ARM64. But if you're playing around with multi-threading and all those components, you might see stuff. And if you care about nanoseconds and everything, you might see subtle things where ARM64 and certain .NET versions might not work, but you have to figure out which version works for you.
Yes.
I'm also showing the multiple versions of .NET.
Yeah, as you were saying before, this is a two-way door, right? You test it and it doesn't work, or you get worse performance, go back to x86, no problems. We're not going to come after you with this thing.
No, after production deployment in future, any problem can happen.
Maybe, but again, the normal question I get from customers is this going to work? And I said, well, I don't know because I don't know your application, but let's test it. Let's spin it up, let's run it, let's see if it works. And if it works, that's brilliant because it's going to save you money. And if it doesn't, we can go back there.
Thank you, gents. That's great. Couple of announcements to close out. So, Aidan will be presenting to us next month for our November meetup. Looking forward to it. Ephemeral compute using Rust.
Extremely fast Lambda functions.
Nice.
Hexagonal functions. Hexagonal functions.
We're also hatching a sort of sub-series, a new meetup series around SaaS topics pertaining to software as a service. You will probably see the first of those launch early December. That was our last discussion. It's almost a lock-in. We haven't quite published it. You're the first to hear. Lastly, workshops. So who here did the Alien Attack workshop that we ran a couple of times earlier this year? It's great. It was very popular. We've had requests to do more. We've wanted to do more. We've tentatively penciled in a second week of November.
No.
The 9th.
Thursday the 9th.
Which is a Thursday afternoon. Event-driven architectures.
Yes.
We are definitely leaning towards to say it is a workshop of event-driven architectures. We will publish some more details of that shortly. It's happening kind of as we speak, like tonight. Did anyone have any announcements that you wanted to let the rest of the group know about? No?
Reinvent recap on the 14th of December, I think it will be, which will be hosted with AWS. It'll probably be a limited number of people, so if you see it advertised, get on it quick. And we'll share it with the user group so that we can send it out from the user group as well.
Is anybody going to reinvent? No? Okay, if you are, I heard a rumour that the event registration stuff, as in bookings for the sessions, opens at 1 AM tonight, so make sure you're up there doing that. Yeah, otherwise you will not get the book. Yeah. Looking up on the
So, who came here just for the Kindle Paperwhite? Thanks for being honest, Sean.
Me.
Thank you. Here it is. You can have it.
We've got this incredibly hi-fi 21st century lottery wheel type thing. Nick has some kind of magical terminal which actually does real graphics. You'll notice that this is looking a little less polished. It's thinking.
There we go.
Yes. I was looking at that. We're not on the network, are we?
Oh, that's me.
Hey!
Just because it's blurry. Could be anyone.
You see, you could have got away with it. Even sort of like a license plate. Oh, Chris, must be the first session he's missed this year.
Oh, okay.
Yeah.
Yeah, it could be. Yeah. It's not.
It's no image available there.
Sean, hey, are organisers allowed?
I don't know.
I don't care.
Consider it to be payment for all the hard work that you put into the group. Okay, thank you very much, everyone. See you next time.